Hey, all right, we're going to learn how to graph functions, and with x's and y's you can graph on the coordinate plane. So for this, you want to make sure and pick 5 inputs or 5 x's to get your output or your y's, and then you'll take those 2 pieces of information, you'll turn them into an ordered pair and graph them on the graph. So you are multiplying your x by 1/2, so you want to pick numbers that are easy when you multiply by 1/2. So you want to make sure and use even numbers, and then also you need to make sure and pick negative numbers because some graphs will behave differently when you have positive and negative values. So I'm going to plug in -4, and I'm just gonna do the work. So I'm going to plug in 1/2 times -4, and then subtract 1. And that's equal to, let me show you here real quick. So you take 1/2 times -4 minus 1. Well, that's -2 minus 1, which is -3. Then you plug in your -2. 1/2 times -2 is -1, minus 1 is -2. You plug in your 0 for x. Half of 0 is 0, minus 1 is -1. 1/2 times 2 is 1, minus 1 is 0. And then if you take 1/2 times 4 is 2, minus 1 is 1. And then you just take your x's and y's and you turn those into ordered pairs so that you can graph. So this ordered pair would be -4, -3. This x and y is -2, -2. This is 0, -1, 2, 0, and 4, 1. So just graph those on your coordinate plane. So you have -4, -3, which is right here. You have -2, -2, which is here. 0, -1, 2, 0, and 4, 1. And you can see that this makes a line. I can't do this on an iPad, but you need to use a ruler or a straight edge to make sure that this is absolutely straight. And you want your line to go through the entire graph, and you need to have arrows on the end to show that even though we've only specifically placed 5 solutions on this graph, there is an infinite number which is indicated by those arrows that go on forever and ever and ever. So what we can see from this is that even though we didn't figure this out, we can see right here that that is also a solution to this equation. Any point that lies on this line is a solution to this equation. This works many times in the real world. So we have a conversion for Fahrenheit and Celsius degrees. So for every Celsius degree, there is a matching Fahrenheit temperature, and we have this formula that someone figured out, it works every time. So I want to figure out what my degrees Fahrenheit will be based on what my degrees Celsius is. So all I'm going to do is I'm going to plug in some Celsius temperatures, and I'm going to figure out the matching or the equivalent Fahrenheit temperature. So I chose my Celsius temperatures on the left. Those are my inputs, my X, or in this case, it's, we're talking about Celsius, so I put C above that. And then I'm just going to plug those in to get my output or the results. So I'm going to take 9/5 times -20 and then add 32. Well, if you do the cross canceling, this would be -4, so that's -36 plus 32 gives you a -4. If you plug in 0, 9/5 times 0 is 0 plus 32 gives you 32. If you plug in 20, you take 9/5 times 20, which is a positive 36, plus 32, which is 68. And I'm actually going to stop there because I think you'll get the idea. So what you're going to do is you are going to graph those. Now be mindful, you can't go by ones. Look at your values here. You're going by, -20, and then your temperature goes up. So be mindful of what your intervals are, and you'll want to make sure and mark those if they aren't intervals of 1. So you might want to pick intervals of, on this graph, you might want to do 10. So -20 would sit, if we're going by 10, -20 sits right here, and the temperature at that point is -4. And if I'm going by 10, again, this is going to be really small and not the most accurate, but that would be -20, -4. Then if I'm going then I'm going to plug in 0.32, and if this is, again, going by 10, 0.32 would be about here. I'm going to make it a little bit bigger. It makes it less accurate the bigger it is. But then when I plug in a positive 20, it's 68. So again, each interval, I'm going by 10. So 20 starts here, and my x value is 68. So that's going to be pretty close to, 70. So if I'm going by 10, that would be on the 7th y going up. So 1, 2, 3, 4, 5, 6, 7. It's a little less than that. Now you can already see this trend, which I want you to do 5 values to begin with. 3 works. So you can see this is a linear function, and you would, see, that's exactly why you need to use a straight edge, because if you don't, it is not accurate. But this is your linear function, so you could plug in any degree Celsius and figure out what the Fahrenheit would be. So if you wanted to figure out 30 degrees Fahrenheit, you could come over here to where 30 degrees Celsius is, and you could figure out what the temperature is without necessarily going through all of the math. Another key idea in this section is to know the difference between continuous graphs and discrete graphs. Continuous graphs, go on forever, where you can figure out a value in between the given values. So for example, if you're talking about, distance traveled over time, even though 45 is not on this, you can see that 45 is between 60 minutes, and you could figure out that if you drive for 45 minutes, you can figure out the distance. It's continuous. You could figure out 46 minutes. You could figure out 47 minutes. It's all, those are possible values that you might drive. In a discrete graph, it's not necessarily continuous. It's, you can't have a part of something. So the example on this discrete graph is bus trips and the number of people. Well, you can see that there's just one dot here for 1, and it looks like 25 people went on the first bus trip. If you look for number 2, that bus trip was 20 people. Well, the difference here is you would not come between these two values and ask yourself, okay, well, how many people went on 1.5 bus trips? You don't count bus trips in 1.5. It is just one, you go by the whole numbers. So continuous graphs you would use if you can find for values in between, or, for partial values. And discrete graphs are, those examples where you can only figure out the information for the whole numbers. So 1 bus trip, 2 bus trips, 3 bus trips. You would do that for cost of tickets. You wouldn't buy 2.5 tickets. You would find the cost for 1 ticket, 2 ticket, 3 tickets. So continuous, again, goes on forever. And discrete, you can see the individual dots over there, and those are for pieces of information that you only want the whole numbers. I mentioned that the cost of baseball tickets would be an example of a discrete graph. So you could create a table and find the cost of baseball tickets. So let's say that baseball tickets are $10 per ticket. Well, if you buy 1 baseball ticket, the cost is going to be $10. If you buy 2, the cost is going to be $20. 3 will be $30. 4 will be $40, and so on. And then, you could throw in 0 if you wanted to as well. If you buy 0 baseball tickets, the cost would be 0. So you want to take this and graph this. This is another example of, this is all positive information. There's no tickets that's going to cost negative money. So when you are only working with positive, you only have to work in the first quadrant. You'll see graphs that look like this only in the first quadrant, quite frequently. So our independent variable is the number of tickets, and our cost depends on the number of tickets that we buy. So make sure that you label, and make sure that you are mindful of your intervals. I gave you information for 1, 2, 3, 4 tickets, so that makes sense to use an interval of 1. So there's 1, 2, 3, 4, and you could do this all the way through if you wanted to. And then cost, it wouldn't make any sense to go by ones because you wouldn't have enough room. So maybe for this, maybe we want to go by fives. So 5, 10, 15, 20, 35, 40. All right, so then from here, just make sure that you graph those. So one ticket, we said, was $10, and 2 tickets is 20, 3 is 30, and you can see what's going to happen here. It makes a nice straight. It's a consistent pattern. It is a linear function, but you don't necessarily have to make the line because you wouldn't ever find the cost of 1.5 tickets. This is an example of a discrete graph with distinct isolated points. Last but not least is learning how to graph non-linear functions. This first one is an exponential function because it has x squared. And again, you just select your x and y values. You can choose your own. You'll learn that there are easier ones to pick than others. Make sure that you choose some negative values, and it makes sense to go in a pattern because then you can check for consistency. So my favorite go-to values are -2, -1, 0, 1, and 2. I plug all of those in as my input, my x, to get my y, or my output. So the very first one, -2 squared is 4, plus 1 is 5. If I plug in -1, -1 squared is 1, plus 1 is 2. If I plug in 0, 0 squared is 0, plus 1 is 1. Then I plug in +1, 1 squared is 1, plus 1 is 2. And 2 squared is 4, plus 1 is 5. And then you go over and you graph those ordered pairs. So -2, 5 is my first one. And then I have -1, 2. And then I have 0, 1. And +1, 2. And +2, 5. And again, this is kind of hard for me to do on the iPad, but if you graph this, this makes the shape of what is called a parabola, which is what exponential functions make. Trust me, you will do plenty of these. You will start to see the stretching and the shrinking of this, and just kind of the general format of an exponential function. And then the last one you'll see is an absolute value equation. And again, plug in x's and y's, and I'm going to choose, this time I'm going to do -5, -1, 0, 1, 5, just to show you you can pick different values. But if you plug in -5, the absolute value of -5 is 5, plus 1 is 6. If you plug in -1, the absolute value of -1 is 1, plus 1 is 2. If you plug in 0, the absolute value of 0 is 0, plus 1 is 1. The absolute value of 1 plus 1 is 2. And the absolute value of 5 is 5 plus 1 is 6. And I'm actually going to grab a different color. I should have done that to begin with. But now I'm going to graph this. So my first one is -5, 6. So 1, 2, 3, 4, 5 to the left. 1, 2, 3, 4, 5, 6 up. Then I have -1, 2. Then I have 0, 1. And 1, 2. And then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. And you can see, it's a little bit hard to see, but your absolute value graphs will actually create graphs. Oh, that's terrible. Sorry about that. Again, you should be using a straight edge. It should look more like this. And again, after we do a few more, after you practice a few more, you will see the difference between absolute value graphs and exponential graphs. In case I haven't told you yet, we are about to start the most exciting part of algebra. Graphing equations and seeing how all of this works together is awesome.